Hello everyone, and welcome to my channel. This is a channel that is dedicated to educating the public on new and exciting and old um, and ancient theories of everything, um, tour de force, magnum opuses, um, you know, uh, theories and philosophies that have taken that took generations to develop, that may be lost to history or losing to history, and anything else that could enrich your life if you knew about them, if you knew about it, and they could enrich your life in manifold ways. Because they are holistic and all-encompassing theories. And today is our 391st video that we have done on the reciprocal system of theory from a man named Dewey B. Larson. And Mr. Larson was born in 1898 in North Dakota and became an engineer, moved out to Portland, and around 1930 he had some epiphanies about the nature of the universe while he was working on much more mundane problems. And he didn't quit his day job, but at night he kept pursuing these more universal problems until 1959, when he put out his two fundamental postulates about how the universe operates. The basic constitution and nature of the universe. And then over the course of the last 30 years of his life, he took these two postulates, and through a process of deduction, he developed a theoretical universe. So this was Larson's own universe of how everything operated, and including compiling theoretical data about all kinds of different empirical qualities that the universe would have, such as all of the different elements and compounds out there and their basic properties, such as their melting points or their boiling points or their compressibility, their valences, also the astronomical bodies, what were their, how far away are they, what are their periods, if they are, something like a pulsar, or if they're a planet, what are their rotation times? All of these different qualities of the universe that have been measured and observed and measured and compiled by the armies of scientists from years past, Larson recreated in his theoretical universe. So while the scientists were spending billions and trillions of dollars and hundreds and thousands of man hours putting all of this stuff together over decades and centuries, Larson did it all himself in his own head with a slide rule on his armchair or his couch. During the evenings, while he was relaxing, or while he was supposed to be relaxing. And so that is interesting, and I think should be followed up. Uh, how was Mr. Larson able to do this? Well, you would think that it must be related to those fundamental postulates. He must be onto something with those fundamental postulates to be able to deduce the universe strictly from theory. And then, he wrote books on those subjects. So Larson has written 12 to 15 books on mostly the sciences, but he has a couple books on economics, and he has one book on metaphysics. And then, mostly on the physics and chemistry and astronomy. And I believe that those books are a treasure trove of potential investigation, that if we understood where Larson was coming from, not to say that he got everything right. I believe that his theory is correct. Whether he was able to plug his theory in correctly in all situations, he admitted that that was a different question, and that he may have made some mistakes along the way. But he also believed that those mistakes would be corrected eventually by other people who were also up to date on his theory, and they would recognize various inconsistencies. And the when you have a generalized theory, when you have a complete holistic theory about things, then the mistakes will eventually become apparent. And I think that's happened. Larson died in 1990, and since his death, and even toward the end of his life, a few of his his conclusions have been altered, particularly having to do with the photon, having to do with electric and magnetic charges, having to do with the geometry of the universe, and some other things, symbolism, and I believe that Larson would have embraced these findings had they been presented to him in a manner that was convincing. He wasn't clinging to his his interpretation. He recognized that he was one person, and that he was doing the job of an army of scientists, and therefore wasn't going to be able to complete the job. And so I think he would have welcomed any type of people that were, as long as they understood the theory, as long as they understood the theory and understood how to apply it, then I think he would have embraced those changes. Now, I guess from here, we just want to go over the two fundamental postulates and see where we're starting from. The vast majority of the work is done with the first postulate. The second postulate is just outlining the math and geometry of the universe. Second postulate is just that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. A number of Larson's followers have taken an issue with that second postulate. particular the Euclidean geometry part and the commutative mathematics part and the primary magnitudes part. And so, you know, that's something that I think is going to be, you know, hashed out over the years, but that Dr. Bruce Perret, I think, has convinced me that Larson's Euclidean geometry is only part of the story, and Perret proposes what he calls projective geometry, or not just, it's not just he that calls it, that's what it's called by the people that have discovered it and so on. It goes back way back, even to ancient times, but especially to the 16th and 17th centuries. Gerard Desargues and a number of other mathematicians since him in the 16th century, but especially in the 19th and 20th century, projective geometry evolved, and Perret pointed at this geometrical cascade, where we move from projective geometry to affine geometry to metric geometry, and then finally to Euclidean geometry. So Euclidean geometry is a subset of projective geometry. So Larson wasn't necessarily wrong, but just not inclusive enough in his understanding of the geometry of the universe, according to Perret. And in my opinion, but I'm no expert. I'm just kind of trying to weigh it out. I could change my mind. It wouldn't take that much evidence to do it. And but now if we look at the first postulate, the universe is composed of one component. Universe is composed entirely of one component: motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Okay, so that's why he calls it the reciprocal system, because the universe is made out of motion, and motion is the relationship between space and time, which sets up a generalized reciprocal relationship between space and time. And so, you know, that's kind of what we're looking at. Now, when Larson is talking about motion, what he's really referring to is what he calls a scalar motion. This is not, when you know, talk to a scientist or whatever, this wouldn't be the understanding that they would glean from the term motion. Normally, motion is thought of as a vectorial motion, a motion that has a magnitude, but it also has a direction. You know, the car is moving 15 miles south by southeast, 15 miles per hour south by southeast. And a scalar motion is a motion that has that magnitude, but it has no specific direction. And you can envision the scalar motion using a balloon with dots on it. If you blow up the balloon, all of the dots are moving away from each other, but they're not moving in any specific direction. Every dot is moving away from every other dot. And in fact, even the locations between the dots are also moving away from each other. Every location on the surface of that balloon is moving away from every other location. But they're not moving in any specific direction. The only way that you're going to get specific directions out of it is if you arbitrarily decide that one of these points, one of these dots, is going to be the reference point. And once you make one of them the reference point and say that this particular dot, we will assume that this dot is motionless. Once you kind of stop the universe that way by saying, okay, we're stopping right here, this one's not moving, then you can determine the directions for all of the other dots. So that is basically meaning that the directions are not an aspect of the motion, but they are an aspect of the reference point. So you're making the reference point that is creating the directional aspect of the motion. Otherwise, we have a scalar motion. Everything is moving away from everything else. That is the motion upon which Larson builds his universe. So the universe is made out of scalar motion, and motion, which is the relationship between space and time. And so motion is basically a fraction with space or time as the numerator, and time or space as the denominator. All of our scientific entities are motions, such as speed. Speed is space over time. The bicycle's moving 15 miles per hour, 15 miles of space and 1 hour of time. But also energy. Energy is time over space. It took me 3 hours to move that thing a half a mile. 3 hours of time, half an hour of space, or half a mile of space. And then we have all of our other scientific quantities, including matter and force and acceleration and electric charge and magnetic flux and electrical capacitance and viscosity and fluidity and power and temperature and pressure. All are relationships between space and time. Time and space as reciprocals, just like any other reciprocals, they have identical qualities, but they are in reverse order. Time and space also do not exist independently. They only exist together in motion. And they both have a three-dimensional aspect to them, which is somewhat of a fiction that Larson calls coordinate time and coordinate space. Well, kind of when you are in a gravitational system, then time and space appear to be three-dimensional and stationary, just like we observe space as x, y, z coordinates or volume in a situation where time is always getting later and later and later. Time is getting later and later and later in no specific direction. That is a scalar motion. But the space is coordinate. It's a still frame. And because of the reciprocal postulate, we can also extrapolate and say that time has the same qualities and space has the same qualities, so that time also is got a three-dimensional aspect, coordinate time, and that space is also progressing, meaning it is not getting later and later and later, but getting farther and farther and farther apart, but in no specific direction. And then also that space and time come in only discrete units. You have to have a full unit of space or time before you have anything. Space and time are quantized. There is a quantum of space and time and motion. And if you have 1 unit of space in 1 unit of time, you have your quantum of motion. You have the speed of light. The speed of light is what Larson refers to as unit speed. 1/1 equals 1. And unit speed is the background of this reciprocal system universe that Larson has originated. That this is the background, the null point, the neutral point, the 0 point, the origin, the ether, the reference point of this universe. So if you have an entirely universe of nothing, you have nothing in Larson's reciprocal universe, you still have the outward motion at the speed of light in all directions. So that is the background, omnipresent, always existing motion of the universe. And so that is your reciprocal one. One is always, in a reciprocal system, is at the center. And then it's balanced out on either side. So one is at the center, and then in the positive direction, you go 2, 3, 4, 5. In the negative direction, you go 1/2, 1/3, 1/4, 1/5. So in the same way, the unit speed is the center, and half the universe is moving faster than the speed of light, half of the universe is moving slower than the speed of light. Larson refers to these as the cosmic sector and the material sector, respectively. And you can see that they're reciprocals because in the material sector, the sector that we're accustomed to, we have coordinate space and clock time. 3 dimensions of space appearing to be stationary, and time is always getting later and later and later. But if we cross that boundary and move into the cosmic sector, then we have 3 dimensions of time, stationary, and we have clock space. Space is always getting farther and farther and farther apart. So the relations are identical, except that space and time take on the opposite roles. You switch the roles of space and time, whether you're in the cosmic sector or the material sector. Okay, now today we're going to finish up this article that is called Science Without Apologies, that Larson gave a talk in 1979. And he first went over the article. In the first part of the article, he talks about how science has not fulfilled its mission, even though it's got some great successes. It does not have a generalized theory. It's a hodgepodge, a patchwork of all kinds of different theories, depending on what subject you're talking about, that don't fit together very well. And he shows how his theory is a generalized theory and is really the answer to their dreams, to be able to have a holistic theory, to be able to see the whole picture. And but unfortunately, it requires the scientists to make so many adjustments that they're not comfortable with that, and so they end up rejecting Larson's theory if they ever hear it in the first place. But he goes over some of the highlights of his reciprocal system and shows that it is a science without apologies. That the science that Larson proposes does not have to, you don't have to apologize for it not being complete. You don't have to apologize for you not understanding all the various aspects. It is fully, complete in and of itself, and it just needs to be fleshed out. Okay, so we're going to start here. He had just gotten done kind of identifying the nature of matter and how that there are going to be 117 different elements, 7 subatoms, and then there are also going to be the reciprocal aspects of those in the cosmic sector. Identification of the inverse units is facilitated by recognition of the fact that the properties of the units are also inverse. For example, if one of the normal double units has mass m, the reciprocal unit has mass 1 over m. For reasons which are not quite so obvious, the life of those inverse or reciprocal units is very short in an environment in which the normal units predominate. With the benefits of this information, we are now able to identify the different basic forms of matter, all of which are rotating combinations of motions. The 117 double units of the normal type are the atoms of the chemical elements. The 7 single units are the subatomic particles. The 117 inverse double units are the transient particles, known by such names as mesons. The 7 inverse single units are what is known as antiparticles. Of course, these conclusions are in direct conflict with current ideas as to the structure of atoms of matter. But it should be realized that all justification for the concept of an atom composed of smaller particles of matter was eliminated by the discovery that matter can be transformed into non-matter and vice versa. This observed fact shows conclusively, as Heisenberg and others have recognized, that the simplest unit of matter is composed of some other entity, an entity we have now identified as motion. It then follows that there is no longer any justification for inventing particles of matter from which to construct an atom, or what amounts to the same thing, inventing hypothetical properties for existing particles to enable them to meet the requirements. Since there are no observable units of matter from which atoms can be constructed without giving them a new ad hoc set of properties, the logical conclusion from the empirical evidence is the same as that which we derive from the reciprocal system of theory. That is, the atoms, the subatomic particles, and the transient particles are all basic units of matter, composed not of smaller particles of matter, but of units of motion. The scope of a general theory of the universe, of the physical universe, is so immense that it is not possible to cover more than a very small portion of the whole in a short overview such as this. But I have shown how the reciprocal system of theory overcomes 2 of the shortcomings of conventional physical science for which apologies are currently being made. The reciprocal system is a general physical theory, and it does provide simple and logical explanations for the basic physical phenomena that have heretofore been so difficult to understand. All right, that is the end of that article. And, there were some difficult parts in there, especially in yesterday's episode. So you may benefit from going over that article a couple times. But otherwise, just let it roll off you. Don't get discouraged by some of the abstract complexity, and I would also recommend that you not reject anything that he says because it flies in the face of some other fact that you've heard. I would just suspend disbelief, let him have his hearing, let him air out what he's trying to say, and then later you can reject it if it doesn't stand up to scrutiny. But don't reject Larson out of hand, as so many other people that I have spoken with have done. You have to take him seriously. He's a serious person. He was a serious person and a serious scientist. And he's being, I believe, honest when he's proposing this theory. He's not a charlatan, I don't believe. And so he deserves a hearing. And then you can, once you are able to kind of see the whole picture, because that's the thing with Larson. Sometimes it seems like he's just pulling stuff out of nowhere, and you're wondering where this. Oh, he just came up with that because it solves this problem that he's talking about. But then you read another one of his books, and he's using the same. The same way to solve the problem in an entirely different field. He is very consistent with his approach, and it's kind of hard to believe that he can use the same approach with atoms as he does with galaxies, as he does with some type of memory or thinking, if he's not onto something. So that's just what I would say is, keep track of Larson's whole theory, and then later on you can evaluate it once you've given him a chance to speak his case. Okay, tomorrow I think we're going to go back into a new article. This one, I believe we're going to try to do this one that's called The Fundamentals of Science in the 21st Century. And this is a talk that Larson gave way back in 1978. So he's predicting how things are going to be in, I guess, the time period that we're in now. So maybe this will be interesting. So come back tomorrow and check it out. Thanks for tuning in today, and have